In this webcast, we're going to focus on using Gaussian elimination to row reduce this matrix until it's in reduced row echelon form. So we'll start with the matrix 2, 1, negative 1, 2, 1, negative 2, 0, 3, 0, 4, 2, 1. Our goal, reduce this until it is in what's called reduced row echelon form. We'll describe that as we get there. We want to use the 2 here to eliminate the 1 below it. So what we're going to do is we're going to purposefully, we're going to take 2 row 2's and we're going to subtract row 1. What that'll do is it'll double this and then remove this row from it, so this will turn into a 2, 1 minus 2, and it'll put a 0 there. When we carry that process out, I'm going to leave row 1 and row 3 alone. Now in row 2, I'm going to take the 1, I'm going to double this, subtract that, giving me a 0. Doubling that is negative 4, minusing that makes it negative 5. Doubling that is 0, minusing that makes it a plus 1, and doubling that is 6, minusing that makes it a 4. That completes our first step. The idea is I want to use this number to eliminate the things below it. If I were on a computer, I'd probably make this a 1 to start with, but then I'd introduce fractions in the middle, and I'm going to avoid fractions for the time being. So now we move to the next. Once I've got taken care of that row, I'm going to ignore, or once I've taken care of the first column, I'll ignore the column and row that contain this number called a pivot. And we now move to the negative 5. I'm going to use this number to eliminate all of the terms underneath it, so I want to now eliminate the 4. To eliminate the 4, I'm going to have to take 5 times row 3 and add 4 row 2's. If I do that, then I'll end up with a 0 down here. So we'll leave the first row and column alone. I now have this negative 5, 1, 4 that I'm not changing, but I now need 5 of those plus 4 of those is 0. 5 of those is 10, plus 4 of those is 14. 5 of those is 5, plus 4 of those is 21. These numbers, the leading non-zero term in each row, are called the leading coefficients. The location is called the pivot location, or the pivot. The columns containing these are called pivot columns. Now we're going to try and do some back substitution, or we're going to work the row reduction now backwards. We'll start on the right, and we'll use this 14 to eliminate the numbers above it. Before I use the 14, let's see if we can simplify this. Notice both of these are multiples of 7. So let's take row 3 and divide it by 7. Doing that gives me, we'll leave everything else alone. We've got a 0, 0, 2, 3. That will greatly simplify our computations as we go. So I'd like to take the 2 and use it to eliminate both of these numbers. So if I take 2 row 2's minus row 3, that'll get rid of this term. And if I take 2 row 1's and add it to row 3, that'll eliminate the negative 1 there. The idea is, what do I have to do to make these 0? And we'll just deal with everything else that happens later on. So now we proceed. If I take 2 row 1's plus a row 3, it turns that into a 4. 2 of these plus that makes it a 2. 2 of those plus that makes it a 0. And 2 of those plus that, 4 plus 3 makes that a 7. That's a 0. Now I want 2 of those plus that, so that's a negative 10. 2 of those minus that. It's negative 10. 2 of those minus that is 0, and 2 of those minus that makes that a 5. 0, 0, 2, 3. Alright, let's take this row, row 2, and let's divide by 5 since it's a common divisor. And doing so gives us the 4, 2, 0, 7 stays the same. The 0, it's now a negative 2, 0, 1, and then a 0, 0, 2, 3. Alrighty, at this point, we've now made zeros above this. So we've got that pivot taken care of. Now I want to take this pivot, and let's make zeros above it. So to do that, if I take row 1 and add row 2 to it, that should eliminate the 2 there. So we've got a 4, 0, we'll add them, add them, add them, and then I've got a 0, negative 2, 0, 1, 0, 0, 2, 3. At this point, we've now put zeros above and below every pivot. That is the goal of reduced row echelon form. Something is in our REF if every pivot has zeros above and below it. And the pivot in a row underneath, so the pivot in row 2 has to be further to the right than the pivot in row 1. Notice that the pivots kind of go down to the right. This is a matrix now that's essentially in reduced row echelon form. The only thing left is I need to make sure that the pivot number is actually a 1. So we'll take row 3 and divide it by 2. We'll take row 2 and divide it by negative 2. And we'll take row 1 and divide it by 4. Doing so gives us 1, 0, 0, 2, 0, 1, 0, negative a half, and 0, 0, 1, 3 halves. This matrix is in reduced row echelon form because the pivots march down to the right. Above and below each pivot are zeros. And any rows of zeros, there aren't any in this case, but rows of zeros have to appear at the bottom. And each of the pivots actually contains a 1 in its spot. What this tells me is the solution to the system is, well, x1 plus 0 has to be 2. I know x2 would have to be negative 1/2, and I know x3 would have to be 3 halves. We've solved the system by just using row reduction along the way. And that gives you an illustration of Gaussian elimination in reduced row echelon form that completes the screen.